Okay, yesterday we talked about proportions, and today we're going to talk about how we're going to use proportions in our similar polygons. So the goal of the day that you'll be able to use proportions to identify similar polygons, and you'll be able to solve problems using the properties of similar polygons. Let's start out with defining what a similar polygon is and talking about the symbol that's used. Similar is like the little squiggly line that's above the top of the congruent symbol. This little symbol here means similar. You'll very seldom see me write the word. From this point on, you'll see this symbol when we're talking about things that are similar. To be similar, corresponding angles have to be congruent. And corresponding sides have to be proportional. And remember, being proportional means that two ratios are equal to each other. So if we look at our figure, A and H are corresponding, they're both equal. Angle D, angle G, angle F and angle C, angle B and angle E. So the corresponding sides would also need to be proportional. We'd write our similarity statement. The order of the first one would not matter. So if I go around this A, D, C, B, if I go A, D, C, B, 1 mark, 2 marks, 4 marks, 3 marks, 1 mark, 2 marks, 4 marks, 3 marks. I've got to go H, G, F, E. And we can see that angle A is congruent then to angle H, angle A, angle H. Angle D is congruent to angle G. Notice they're in the same corresponding spot. Angle C is congruent to angle F. And angle B is congruent to angle E. And again, we can see C and F, B and E are in the same corresponding places. The corresponding sides also need to be proportional. So AD, its corresponding side would be HG. Would have to be the same. I'd go to the next side, DC, over GF. Then I'd go to the next one, CB, over FE. And the last side would be BA over EH. And if I just take a look at a small part of that, that's saying 3 over 1.5 would be the same as 2.5 over 1.25. You can see 1.5 goes into 3 twice, 1.25 goes into 2.5 twice. These are similar ratios. They're equal ratios, so they are proportional. Two polygons are similar if and only if their corresponding angles are congruent and the sides are proportional. And again, if you're using this recording, remember that you may have to pause it at some point in time so the students can write things down. So we have our same two shapes, and you'll see that they wrote the similarity statement, A, B, C, D. They went this way. H, E, F, G. And again, this symbol means similar. The order of the vertices in a similarity statement is important. Corresponding parts must be lined up. It's not to say that everybody will write it the same way, because we've already shown you in this particular figure that we could have done it in a different order. But it does mean that wherever I put A, the corresponding angle to A and H have to be in the same location. So I could have done A, B, C, D. I could have started with B and gone B, C, D, A. So the order matters. The first one you can kind of pick. The second one is determined by the first one, just like it was in congruency. Here it's asking me if these figures are similar. If you take a look at triangle JKL, it is isosceles because two of the sides are the same, which means these two angles will also be the same. There's 180 degrees in a triangle, so there's 140 left, which means the remaining angles are 70 degrees. In this particular figure, I can see that again I have an isosceles triangle. There's 180 degrees in a triangle. There's 50 degrees that are used up. There was 130 degrees left, which means the remaining two angles would be 65 each. Since the angles are not congruent, then no, these are not similar. They're asking me, are these figures similar? And if I take a look again at the triangle here that's on the left, I see I've got 60 degrees and 80 degrees. That's 140 degrees out of 180. So there's 40 degrees left. This angle is 40 degrees. If I come over to the other figure, I have 80 and 40. I've used up 120 out of 180, which means that there is 60 degrees left. Now I can see that all the angles are congruent, and I'm just going to check to see if the corresponding sides then are parallel. The 5.2 is between the 60 and 80. It should be compared to the 3.9. 7 between the 80 and the 40 should compare to 5.25. And then the 8 then would compare to the 6. If I take and actually divide each one of these out, 5.2 divided by 3.9 does give me, it's actually 1.3 that's repeating. 7 divided by 5.25 also gives me 1.3 that's repeating. And 8 over 6 is also 1.3 repeating. So this is proportional. So yes, they are similar. And we're going to go ahead and write a similarity statement. Triangle ABC. Again, the order of the first one really doesn't matter, but the order of the second one does. A was 60, so I need to start with X. Then I went to B, which is 80, so I need to go to Z. And then I'm going to go to Y. So triangle ABC is similar to triangle XZY. When you're talking about a scale factor, in similar polygons. Scale factor is the ratio of corresponding measurements. And it's technically corresponding linear measurement. And the reason it says linear is we are talking about the side, not the angles, because the angles are all congruent in the first place. So if they're looking for the scale factor of ABC to XZY, I can take any of the ratios. ABC, 5.2, divided by 3.9. I could do 7 over 5.25. Or I could do 8 over 6. Now any of these will produce a scale factor. This is the easiest one to work with because there's no decimals. And remember that when we're doing a scale factor, we should, or using a ratio, we should always simplify that and put it in simplest form, which is 4 over 3. I would much prefer to see this as an answer. Then I would see you change something into a repeating decimal, because the 4 over 3 will be 100% accurate. No matter how many places I carried this out, it would only be an approximate value. If they want the scale factor of XZY to ABC, remember that this is really just going to get flipped over. It'd be 3.9 over 5.2, 5.25 over 7, or 6 over 8. Now, when I work this one out, this would be 3 over 4. This one we might write as 0.75 because this decimal is terminating, or we could leave it as this fraction. Either would certainly be okay. They're asking me to find a scale factor here. In order to find a scale factor, these two polygons have to be similar to each other. Okay? If I'm going to find the scale factor, then what I'm going to look at is two sides where I have numeric values. I see 6 and 4. I see 8 and y plus 1. That's not going to help me. I see x and 3. That would not help me. So I have 6 to 4, which is the same as 3 over 2, or a scale factor of 1.5. And again, I probably would leave it as a fraction, and I would leave that scale factor then as 3 over 2. We can use that scale factor and the idea of a proportion to help us find these missing values, which is what we're going to actually do here. Remember that we can take each side, has to be proportional. So the 6 over 4 we said would simplify to 3 over 2. It should be the same as 8 over y plus 1. Likewise, I can take that scale factor, 3 over 2, and it should be equal to x over 3. And we're simply going to work through this and solve these two proportions. So remember the product of the extremes and the product of the means that we talked about yesterday. So we're going to take 3 times y plus 1 is equal to 2 times 8, which is 16. This would be 3y plus 3 is equal to 16. Which means that 3y is equal to 13. And I'm just going to kind of come over here and finish this out. 3y is equal to 13. and then I would divide both sides by 3. And again, it is going to be easier for us if we leave this as an improper fraction versus some kind of repeating decimal, which is what I would get. I am going to cross multiply here. 3 times 3 does give me 9. 2 times x is 2x. And to solve this one, we would go ahead and divide both sides by 2. So x is going to be equal to 9 over 2. This one does come out to a terminating decimal, so I could change it to 4.5. I still think probably going to be easier in the long run if we just leave it as a fraction. Your assignment is again out of the actual book today. You're going to open to page 444, and all the problems that are following that page then, 1 through 4, 9 through 20, 23 through 29, and then 37 and 38.